Welcome to FM Education Academy YouTube channel. In today's video, we'll be seeing B.tech Jntuh 2022 answers of all the options. That is, we'll solve 1A, 1B till 8A and 8B. So, first question is explain in detail the passive and active elements, and it is for 8 marks. I am actually a B.tech teacher, basic electrical engineering teacher. So in my class, when I taught this, I had taught this in a very detailed manner, this answer. So I will share the notes which I had taught in the class. Network elements can be classified as active element, that is called as source, and also passive element, that is called as sink. Source means one which is giving and sink means one which is absorbing. So then active element consists of voltage source and current source. Voltage source is again of two types, independent voltage source and voltage dependent source. Current source is of two types, independent current source, current dependent source. Again, independent voltage source is of two types, ideal voltage source, practical voltage source. Voltage dependent source is of two types, voltage dependent voltage source and voltage dependent current source. Independent current source is of two types, ideal current source and practical current source. Current dependent sources of two types, current dependent voltage source and current dependent current source. So basically there are four dependent sources we have, and then passive elements are of three types, resistor, inductor and capacitor. So if you draw this and explain each one in one or two points, that will be enough for you getting 8 marks. So what is active element? Since they have asked active element, passive element, we'll define what is active element. It is an element which can energize a network, that is, it delivers a net amount of energy. Net means total amount of energy. So example of active element, voltage source and current source. Then we'll define what is passive element. It is an element which absorbs the energy delivered by an active element. Some passive elements store energy. Example, resistor, inductor and capacitor. Since it is telling some passive elements store energy, we know that resistor is a heat dissipating device, but inductor and capacitor store energy. Then we will first active and passive means you will first tell about passive elements and then you will tell about active elements. So passive elements, in that we have R, L and C. So you will define what is resistor. Okay, then you will define what is resistance, symbol of resistor, formula of resistance, then VI relation for resistor. Or you can skip this part. You can avoid writing electrical resistance, and remaining things you have to write what I told. Then similarly for inductor, you will write what is inductor, okay, till here, and then you write the VI relation for inductor and this formula of inductance. Next we have capacitor is also a passive element, so we'll write the definition of capacitor and the symbol of capacitor, the formula of the capacitor, the unit of capacitor. Then we'll write the VI relation for capacitor. If you have time, I suggest you to write capacitance also, but if you don't have time, no need to waste time on writing the definition of capacitance. Next, passive elements are over, R, L and C. We'll come to active elements. So what are active elements? Voltage source and current source are active elements. After writing this, directly we'll write independent voltage source, because already this part we had explained in the flow chart. Okay, so no need to write this. This I had given in the notes when I had explained in the class. Directly write voltage and current sources and then write independent voltage source. And independent voltage source, we have ideal voltage source. As we know, ideal voltage source means one which does not exist practically. It means it will give a linear graph, as you can see here. So this is ideal DC voltage source, this is time varying ideal voltage source, and this is the VI characteristics. You will explain what is ideal voltage source, and then similarly we will write what is practical voltage source, what is time varying practical voltage source, and VI characteristics. Even if you skip this second figure, it is okay, but first and third figure should be there. Then independent current source, ideal current source and practical current source. Okay, so you need these two, and what is definition you should write. Similarly, practical current source, these two graphs, and then what is that you should explain. Okay, next we have dependent sources. Okay, as we know, we have four types of dependent sources, voltage dependent voltage source. So write this, draw. Then we have voltage dependent current source, write this, then draw this. Next we have current dependent voltage source, draw this and write this. Next we have current dependent current source. This is our current dependent current source and its definition. This finishes our first part and you'll get 8 marks if you write all this correctly. Okay. Next, in the first question, part B, it told us a problem. What was the problem? By using Thevenin's theorem shown in figure 1, find the current in the 6 ohm resistor. This is our given figure. A 5 volt source is given, resistors 3 ohm and 5 ohm are given, and 4 ohm and 6 ohm resistors are also given. We have to find out how much current is flowing in the 6 ohm resistor. So we have this answer. Yeah. First, we'll find out the Thevenin's voltage, okay, in Thevenin's theorem problem. So, how to find out the Thevenin's voltage? You have to open the terminals in which it is telling you to find out the current. Since it is telling us to find out the current in the 6 ohm resistor, we are going to open these terminals, okay. So, apply KCL now, KVL. We know voltage across the loop is equals to 0, that is our KVL. So, minus to plus means plus 5. Then here plus minus 3i plus minus 5i is equals to 0. So we have, if we solve this in detail, 5 minus 8i is equals to 0 and 5 is equals to 8i, I is equals to 5 by 8. If you solve in calci, you will get 0.625 amperes. Next we have voltage across 5 ohm we have to find out. So what is the voltage across 5 ohm resistor? It is nothing but it is I into R. I into R means what is the current here which is flowing? We got the current which is flowing is 0.625 amperes because we know that in series current is same. So 0.625 into 5, if you multiply this with calci, you will get voltage across 5 ohms is 3.125 volts. Then Thevenin's voltage is equals to what? Voltage across A and B, that is nothing but voltage across 5 ohm, right? So we get to know that voltage across 5 volt or voltage across Thevenin's is nothing but 3.125 volts. Why it is same? Because we know in parallel voltage is same. Okay. So we got the Thevenin's voltage as 3.125 volts. This is parallel to this, right? That is the reason why Thevenin's voltage is this much. Next we will find out the Thevenin's resistance. Okay. How to find out Thevenin's resistance? We know that these two resistors are in parallel. We can see since it is dividing at this node. Okay, the current divides. The current which is coming from this, it will split here and here. So we can write R1 R2 by R1 plus R2. That is the formula to find out equivalent resistance. R1 is 3 into 5 by 3 plus 5. So first we are going to find out this parallel combination resistance. Okay, equivalent resistance. So 3 into 5 by 3 plus 5, that is 15 by 8. If we divide, we will get the answer as 1.875 ohms. Next, how the figure will become? Instead of this 2, you will have one resistor here. Okay, and one resistor already you have here, 4 ohms. And this is your A and B, and this is your equivalent resistor. And what is this resistance now you will have? Just now we found out 1.875 ohms. Now we know that these two resistors are in series. So we'll add this 4 plus 1.875. 4 plus 1.875 is 5.875. Okay. So we have Thevenin's resistance is 5.875 ohms. Okay. Sorry, once again. What's happening? Yeah. Next, find out the IL. What is IL? IL is equals to VTH by RTH plus RL. That is our load current formula in case of Thevenin's problems. So Thevenin's voltage we had got 3.125 volts. RTH also we got 5.875 volts. And what is RL? RL means the load resistor, means in where we have to find out the current. That was nothing but, remember here it was 6 ohms, so plus 6. If we divide 3.125 by this, if we add directly in calculator, we'll get the answer as 0.2631 amperes. Now what is the last step you have to do? You have to draw the Thevenin's equivalent circuit. How will Thevenin's resistance equivalent circuit be? VTH and RTH will be here and RL will be here. So VTH is 3.125, RTH is 5.875 and RL is 6 ohms. And IL also you are writing here. So this completes a problem. If you do this, you will get 7 marks if you did everything correctly. So total you will get 15 marks for the first question. Next, second question was state Kirchhoff's voltage and current laws, explain in detail. Very easy question, very easy to score 8 marks. But it is telling explain in detail. So here what all you have to write, I'll show you. You already know what is Kirchhoff's laws. I'm not explaining because it is a theory and already you know. I'm just discussing the answers. Okay. So Kirchhoff's current law, you'll define. Then you'll write this definition. Sign convention. You should also write about sign convention. Why? Because that also carries 2 marks. Since it is 8-mark question, you should write what is sign convention. Okay. Then explain this. Then Kirchhoff's voltage law. Then this formula. Then applications and limitations. Okay. So, and the sign conventions for KCL and KVL you should write. I already told you because that is a 8 marks question. If you do this all, you will get 8 marks. Okay, next question is 2B question. By using superposition theorem, find the current through the 2 ohm resistor. So this is also a very easy question. See the figure carefully. You have 1 volt here, you have 1 ohm, 1 ohm, 2 ohm, 3 ohm and 1 volt here. And you have to find out the current flowing through the 2 ohm resistor. This current which flows through 2 ohm, you have to find out. So here, what we should do, remember in superposition theorem, we have to keep one source active at a time. So here I am going to first keep 1 volt active and I am going to open circuit 1 ampere source. So here first mesh over here is what, if you see, it is nothing but voltage across 1 volt minus, here it is going right, 3 into I1 minus I2 is equals to 0. See, this is our first mesh. Mesh means loops, okay. Here we are having, this is my first mesh. So I'll apply KVL to this mesh 1, okay. That is nothing but 1 minus to plus, it goes here plus to minus. So minus 3 into I1 minus I2. Why is it I1 minus I2? Because here we are considering that this is I1, current which is flowing through this branch is I1 and current which is flowing through this loop and branch is I2. Both will flow through 3 ohm only, but both are different. That is why we are doing I1 minus I2. Why are we doing I1 minus I2? Because first it is going to I1 and then it is going to I2. So now if you solve that, you will get 1 minus 3I1 plus 3I2. Minus into minus is plus is equals to 0. So you will have minus 3I1 plus 3I2 is equals to minus 1. Let that be equation 1. Now similarly, what is your mesh 2 if you observe? Mesh 2 is this mesh. So you can write minus 2I2. Okay, we are considering the current which is flowing through this is nothing but I2. Okay, so how I will writing minus 2 into I2 because V is equals to IR we have now. We are applying KVL to the meshes because we know we apply KVL to the loops, right? So minus 2 into I2 minus 1 into I2, then it goes here, that is nothing but minus 3 into I2 minus I1. Why is it I2 minus I1? Because here we have I2 and here we have I1. Okay, so now minus 3I2 we have because it is minus 2I2 and this is minus 3I1. Yeah, minus into minus is plus 3I1 we have here. Here we have minus 1I2. So minus 2 minus 1 will give us minus 3I2 and here also we have minus 3I2 if you open the bracket. So we'll get minus 6I2 and plus 3I1 is equals to 0. That is our equation 2. Now what you can do is you can solve this by using calculator. Okay, you have the options in the calculator, right? You have to use the options in the calculator to solve these two equations. Okay, which equation? Yeah, this equation and this equation. You have to do this with the help of calculator. Okay, you have a matrix now. You have to click matrix on the calculator and you have to do. Okay, so next we have, first what did we do? Remember, we had kept 1 volt source active and we have opened this current source. Now what we'll do? We'll short this 1 volt and we'll keep this 1 ampere active. Okay, so see here, we are keeping 1 ampere active and we have shorted this voltage source. Remember, voltage sources are always shorted and current sources are always open circuited. Now what are we doing? We are finding out the current across the 2 ohm resistor. How to find out? We have a formula, IT into RP by RI plus RP. What is IT here? IT is 1 here. Okay, that is nothing but the resistor opposite to 1 ampere into RP. RP here is 0.75. Okay, parallel resistance. How will we get the parallel resistance here? So here if you see in this diagram, we have to find out the current through the 2 ohm resistor, right? So to find out the current through the 2 ohm resistor, we know that 1 ohm and 3 ohm are in parallel to this 2 ohm. Because here we can see that we have a loop and whatever current flows through 1 ohm, it will split here. Similarly, here also current will split in these both branches. So it is parallel, right?
this current flowing through 2 ohm is parallel to 1 ohm and 3 ohm, right? So here we can see that 1 ohm and 3 ohm are in parallel with respect to 2 ohm. So the formula for Rp will be R1 into R2 by R1 plus R2, that is 1 into 3 by 1 plus 3. 1 3 is 3 by 3 plus 1 is 4, 3 by 4 is 0.75. So in place of Rp substitute 0.75, here we have substituted 0.75 and It here is 1 amperes. So by Ri is 2 ohms, where we have to find out the resistance, that is called as Ri, plus 0.75. So we get that the current flowing through 2 ohm is this much. So what did we get current flowing through 2 ohm? When we kept the other source as active, we got the value of current flowing through 2 ohm as 0.334 amperes when we kept this source as active. Okay, so we have add both the currents. We know that, right? The current obtained will be equal to current flowing through individual sources. So 0.334 plus 0.2727, if you add, you'll get 0.607 amperes. So that is my answer. Next we have the question. First what we'll do is we'll solve 6A, 6B, 7A, 7B and 8A and 8B, and then we'll solve the remaining questions. So I'm just sharing the slides with you for these questions because these are theory questions. Okay, you guys might have already prepared. So just check whether your answers are correct or not. So 6A is explain significance of torque, slip and characteristics of three-phase induction motor. This was the answer. Torque slip characteristics. Okay, low slip, medium slip, high slip. Okay, these characteristics and explaining the parts, what happens when slip is 1 and is 0. Next question is 6B question. Why three-phase induction motor not rotating at synchronous speed? Explain. So this is my answer. Next we have 7th A question. Explain the types of batteries and its important characteristics. So these are my types of batteries. Lithium acid battery, nickel cadmium battery, nickel metal hydride, lithium battery, SMF battery and their applications. You can write. Okay, for this what you can do is instead of writing the applications, okay, just write the types of batteries in detail. What is lead acid battery, what is nickel cadmium battery, what is nickel metal hydride battery, what is lithium battery and what is SMF battery. You write about it in detail. Okay, that is also there in textbook. No need to write applications. Okay, just explain what are all these. It is there in the textbook. Okay, you can go through it. It is also there in BWD code. Okay, so just write all these 5. What are they? Explain them. Okay, next write the battery characteristics. These are battery characteristics. Okay. Nominal voltage, battery capacity, all these are characteristics of battery. Okay, so we have 7th A is over. 7th B, define earthing and explain the purpose of earthing. So this is what is earthing, necessity of earthing, importance of earthing. There is nothing but necessity of earthing. Okay, which question is it? 8th A, constructional details of synchronous generator. What is 7B? V is over. Why single? Okay, sorry, 7th A is this question. Constructional details of synchronous generator. You had to explain what is stator. Okay, then you had to explain what is rotor. You know, in synchronous generator we have 2 types of rotor, salient pole and projected pole type. So salient pole, projected pole type and non-salient pole. 2 types we have and you have explained both of them. Next we have why single phase induction motor is not self-starting. This is our answer. You have to explain why single phase induction motor is not self-starting with the help of double field revolving theory. You know there are two types of fluxes, right? Forward flux and backward flux. With respect to that, you have to explain. Okay, and with respect to the stock slip characteristics also you can explain. Just go through it. Okay, next we have the question number 3A. Explain the following terms of AC circuits. RMS value. What is RMS value? We are explaining. Then what is average value? Then what is peak value? Second is average value. Third is peak value. This is our peak value. Fourth is form factor. Next we have phasor and phase difference. Phasor and phase difference. Okay, is explained in detail. Next we have yes, this question. Analyze the series RL circuit with a neat sketch and also draw the phasor diagram for it. So we have to explain what is series RL circuit and we have to draw it also. So this is our answer. Series RL circuit and drawing the phasor diagram. Okay, with respect to this, VR is IR, VL is IXL. Next question is 4A. Relation between phase voltage and line voltage of a balanced three-phase star connected system. Next question is circuit consisting of 3 branches. This problem, it's very easy problem. See, 3 impedances are given to us in the question. Total voltage is given and frequency is given. So first find out what is I1. First, this is known as rectangular form. You have to convert rectangular form to polar form. Okay, this also you have to convert rectangular form to polar form, rectangular form to polar form. How to convert that? With the help of calci. You have options in calci how to convert rectangular to polar. So after getting Z1, Z2, Z2, find out I1, I2, I3 because it is telling in the first bit to find I1, I2, I3. I1 is V by Z1, I2 is V by Z2, I3 is V by Z3. V is given 100 means it is 100 angle 0. If you divide this 100 by 15.81 you will get 6.324. This is nothing but 0 minus 71.36. You will get this. You can easily divide. In case of angles you have to subtract if it is division. So 0 minus 63.43 is giving you minus 63.43. Similarly here also 0 minus 75.96, 75.96. But these values you will divide with calculator. So we got I1, I2, I3. Now to find out V1, V2. We know V1 is equals to I into Z, so V1 is equals to I into Z1 and V2 is equals to I into Z2. Whatever values you are getting, you have to multiply those. Okay, so if you multiply 15.811 into 6.324, you should get the answer. Okay, and then subtract these both. Similarly, V2 also. Multiply 17.8 into 5.59, you will get 99.94. And subtract this both, you will get 0. So we got V1, we got V2. Next question is explain losses in transformer, also derive the maximum efficiency. So losses in transformer, these are losses. Loss. Okay, before losses in transformer. Okay, sorry, we have to do 4. This was which question? 4 for a B. What is 5A question? EMF per turn of a single phase. Okay, this is given. Just see the question and see the answer. This is the equation of transformer, EMF equation of transformer. E is equals to 4.44 F phi m. We are finding out phi m, and with the help of the formula E1 is equals to 4.44 F phi m into N1, we are finding out N1. Similarly, we are finding out E2. With the help of the formula E2 is equals to 4.44 F phi m into N2. N1 and N2 will be different for primary and secondary. Okay, so that is how you got N1 and N2 with the help of EMF equation of transformer. Okay. Okay, next we have second bit. We have to find out flux density. We know flux density is equals to flux by area. So find out flux, find out area by dividing this. Okay, area unit is meter square. Next question is losses in transformer and maximum efficiency of transformer. So these are the types of losses: core loss, iron loss, eddy current loss, copper loss. Okay, hysteresis loss. Okay, condition for maximum efficiency derivation. So already we discussed 6A question. So this finishes all our questions. See, we have done 5A, 5B, 6A, 6B, 7A, 7B, 8A, 8B. Questions we had discussed, and also we had discussed first, second, third, fourth. First, second, third, fourth. Okay, so we have discussed all the questions. This was your answer key. I have gathered all of them together, okay, for you all in a PDF. Thank you very much for watching. If you found this video helpful, like this video, share these answers with your friends, okay, to check the answers, and subscribe to our channel. Stay blessed.